Good morning, everyone. Thanks for joining me. My name is Mike Reed. I'm a BI consultant here at Pragmatic Works. Currently delving into big data and having a lot of fun at it. So I decided I would share my, try to share my enthusiasm with everybody. This is part 2 in a 3-part series. 2 weeks ago in part 1, I walked through a number of, well, I'll just show you. Pull this up real quick. I walked through a number of scripts. I was focused pretty much on Azure. Walked through a number of scripts I wrote that will spin up an HD Insight cluster and load data into it, etc. I really talked about the environments to work in. It was very much Azure-centric. I do, if you go to my website, have information on how to set up the Hortonworks sandbox, and I'm working on some other experiments for that. Please check that site if that's what you're more interested in. There is certainly some cost to the Azure side, so if you're not prepared for that, then you might want to play with it a little, at least use up your trial anyway, but you might have to call it quits after that. Right now I'm running a bill of $50 to $70 a month for what I'm messing with. And it's not heavy duty at all. It really does, it's a little off topic, but really does come down to managing your hours. So what are we going to talk about today? So beyond the basics, I'm really focused on analytics. If you watched my last webinar, I made the statement that without analytics, without actually extracting value from all this fun we're having, I guess, with Hadoop and the big data, etc., then whoever's paying for this is not going to be happy. You have to extract insights, and hopefully ones they don't know, and they need to be actionable as well. So there's in the cycle of analytics, there are a few steps here that we'll walk through. To do any sort of analytics, you really need to identify the problem, even if the problem is, I want to know what I don't know about my data. That's actually a very clear question, but it's obviously very open-ended. In most cases, you may have a more specific problem. I want to reduce the outages of my equipment, or I want to anticipate when something is going to go wrong. I want to anticipate what my sales are going to be, or what demand is going to be for inventory, etc. So identifying the problem is a huge piece, because once you understand the problem, then you can move on to preparing your data, because your data needs to support the problem, and you may or may not have the data to do it. It may be something I'll talk about in week 3 is the questions to ask of your data. I might propose that a lot of businesses really need to be introspective before they start, thinking about, well, I really need some sentiment data, because they may or may not actually be able to manage, may not be doing the best job they can to managing their business with the data they have. And from what I understand from people I've interviewed that would be qualified as experts, that's very frequently the case. Once you preparation of the data, does your data support the analysis of your problem? The next step is to choose a mining model. There are all sorts of models. Some will fit, some will not. The data you have prepared will very much determine what kind of model you can run on it with any sort of probability of extracting something that's really useful, better than a coin toss. And that is actually the ultimate test, is how well did we do against a coin toss. Choosing a model, that kind of works back. There may be a little bit of a cycle there. You may have to go, well, I really want to run this model because it'll tell me this stuff, or the model I thought I was going to use doesn't work, or it doesn't tell me what I want, so you may have to cycle back to preparing your data again. So anyway, once you've chosen your model, we would move on to test and train the model, and that typically involves a series of certainly more than one and generally a lot of iterations through selection of what they call independent variables. These are the variables that determine the output. They're used to predict your output, and you may or may not have all of them. You may choose the wrong ones. That's kind of a that's an easy place to have a giant problem, is figuring out what parameters, what inputs, what columns, what data you really need to be looking at that best identify and predict the outcome you're looking for. Experience at Microsoft in the behavioral targeting group. I heard over and over again, there were a lot of people that were fixated on, well, I'm using 38 properties or whatever, when the seniors in the group were saying you really need it. You really are looking for 2 or 3 or 5 or something that you can actually manage and control. So once you've developed your model, you test and train. And testing means running your algorithm. Training means running your algorithm on a representative set that wasn't used in the test, and looking to see if you've actually if the prediction actually fits or improves your output, if it gives you the results you're looking for and the margin of error is reasonable. If your model doesn't fit, then your probabilities and margins of error will be high, and once you get too high, you might as well go back to a coin toss. And last, which is kind of a two-step deal. One is you have to deliver results, or you need to prepare the output and get it ready for some sort of visualization. You need to take all this stuff that you've done that can be a lot of gobbledygook to anybody that doesn't know analytics somewhat well, or to some degree. It's certainly not going to mean anything to most execs, unless they've been in this end of the business for some time. You're going to have to explain it to them in terms that they understand. And that's really important, because you're going to need to convince them that you've come up with results that are actually correct and actionable. So let's start with our data. Data, one of the big things with the whole NoSQL Hadoop thing is that we just load data in. We don't have schema on read, or schema on write rather, like we do in our relational data models. We have schema on read. So now this is when we have to pay the price. So this data it's an aviation incident file from last year, I guess 2012 looks like, and all of this looks pretty good. If you were to run some sort of algorithm looking for keywords in here, trouble, engine, and associations, how far engine is from trouble, and struck something, blah blah blah, this wouldn't look too bad. In the same data set, we have this, where now we have the wrong stuff in the wrong place, or the right stuff in the wrong place, whatever it is. We have inconsistencies, we have blanks. Points up the need to really clean up your data and to make sure that it meets these particular characteristics. So accuracy, is your data known to be good? Does it smell good? I mean, we're all in the data business, so it's pretty easy to go through and see, well, is the data type consistent? Are the values in the columns consistent? So at least it's formatted correctly. Is the data complete? Does it actually, for the analysis I want to do, is there an appropriate set of, referring data science stuff, independent variables? Are there appropriate inputs to determine the output you're after, or to fit the model you're considering using? And is there enough of it? if your sample is too small, it may not be representative. So both of those can greatly influence your outcome. And in all this data science stuff I've been doing for the last 8-9 months, that's one of the big deals, is making sure that your data is such that you understand it, you understand its behavior, and you understand what's in it. Is your data relevant to what you're trying to do? Is it missing things? If you're trying to do, how do people feel about this? Do you have your sentiment? If you don't need the sentiment, is it there but it really doesn't belong there, and it's influencing things in the wrong way, or confusing your models? Reliability. Can you trust what's in there? This comes back to the repeatability and the reproducibility. Can you process your data? Does it look the same, and do you get the same sorts of results every time? It's unlikely that you will run any algorithm just once if it actually proves to be useful. You'll probably run it on a recurring basis, and can you count on it based on your data to give you the same positive effect that you found in the first place? And is it accessible? Are you using data that won't be available, and you're building some business process that is dependent on this, or is or at the very least you need to be aware that we're going to have this for this period of time, and then this data is going to evaporate because of some global situation, whatever. So data cleansing. Let's pull up. I'm going to bounce over to Excel. I know everybody. Well, it's kind of a lot of love-hate relationships with Excel, but quite frankly, mine was a hate relationship until, or dislike, let's put it that way, until a couple of years ago. At this point, with everything, Microsoft has made so many advances with Excel that it's really a very useful tool, and they've built it as a front end to so many things that it'll connect to almost as many things as SSIS will now. So,
hey, Michael, sorry to interrupt.
Obviously a great.
Sorry, you're breaking up.
Yes.
You're breaking up just a little bit. So if you wouldn't mind, maybe try closing. If you have any extra internet programs open, to try closing those and see if that helps.
Okay. I've got a few browsers open. Beyond that, I don't.
Okay. Yeah. If you could try closing those out, that'd be great.
Okay. All right. Is this any better?
Yeah, you don't seem to be breaking up right now. It's just occasionally, so just wanted to address that.
Okay.
Thanks.
Okay. All right. Thank you. If anybody has any issues with quality, whatever questions, please type them into the chat window. Liz will pick them up and forward them on to me. So Excel is a great place to start. It's obviously very easy to move things around. It connects to everything. It then also, as we know, imports the data. You can use Excel, as I showed in part 1. You can connect to your Azure or almost any other store, whether it's Azure or Amazon, or it's via. I'll stop there. You can connect to almost anything, so it's a really nice way to grab your data, contain it, and in my case, I chose this partially because of all the data mining capabilities of Excel. So in addition to cleaning your data here, we have the ability to go through and do some classification. We can understand our data a little better, do some profiling. If you haven't looked at data mining in Excel, you should. So understand that this is actually a front end to the SQL Server data mining algorithms. And so this requires an instance of analysis services to be running in the background, 2008 or better. With the data mining plugin, you set your connection here. This is my the analysis services instance I'm looking at. So what this does, it takes data from here, pushes it off to analysis services along with the specifies the model, provides the inputs for the model, runs it, returns it all here. So it's a really easy way and a nice way to do some analytics and in a lot of ways make yourself look like a hero. So data cleansing, issues you'll run into, as I explained earlier, I don't think I have a set here that has nasty stuff in it. Maybe there's something called imputing. So if we have a set of data here and we're missing values, what do you do with those? I mean, what do you do if you have nulls? You know, if everything else is relevant or significant, you know, can't be too significant, but some portion of your data is not quality, what do you do with it? You know, there's a couple schools of thought. You know, one, you can get rid of it, you know, but is that going to, if you're looking at, you know, counts of visitors to your website over the last 30 days, you really can't drop everything out because you need those counts. So if you drop them out, then your averages are going to look weird, and you know your entire result set's going to be skewed. So what do you do with them? Do you fill in, you know, one thought is to fill in values with means if it's numeric. Another is to say, well, what are the values surrounding it on either side by, you know, 1 or 2 or 3 levels, and fill in there. The point is, this is to understand what you are doing and document what you're doing to your data, because you may inadvertently skew your results. And you should try multiple methods and evaluate, you know, run your, when you finally decided on your model, do your profiling, run it against multiple scenarios again so you can see what the impact is of you know, using a mean for a numeric value. That was kind of a big deal. It was one of the projects in the data science course I'm doing just a couple of weeks ago. So data augmentation, what's up next? So does your data actually support your analysis? Do you have everything you need? If you're looking internally, do you have all the numbers and, you know, machine specifications? Do you have baseline data? I mean, do you have just what you collected today? Do you have enough of a period to say, well, this is really, I'll use the word representative, but differently here than number 2. Do you have enough data to actually demonstrate a behavior? You may look at data today and go, well, and compare that to the same day last month, but last month might have had a seasonal influence on it, or you may have just released a new product or put a new piece of equipment in or hired a new employee to run something. That sort of thing needs to be considered. So does your data actually provide a baseline and provide enough information to actually demonstrate the changes and really to indicate what your data's behavior is over whatever cycles it may go through. Representative sample is it big enough? If you're looking at quarterly trends, to say that, well, I'm going to use 1 year as my baseline may not be enough. You may need to use 2 or 3 years with notes in there. My third item here, include events and triggers, to understand what may have happened within those years. To speak to that last line, include events and triggers, I rarely see in any data model a dimension or table that includes factors that may influence your operations, your business, Things like, we added new employees, we released a new product, we added a new machine, we opened a new branch, things that could be external. I sell guns and there's a new war that started, or, alcohol's, I guess we're going to, well, I was going to say alcohol, we've started prohibition again, or, whatever it may be. It's important to collect those, especially the ones that are directly related to your business, in that you're going to start seeing anomalies in your data, or you're going to start seeing changes, and you may attribute those to what you're doing with your model, when in fact they're actually based on something you did internally. Also, you need a way to explain, even if your results are correct, you really need to highlight those in your reporting, such that everybody that sees your report has the same picture. Somebody over in marketing may know that you released this product at this particular time, but somebody over in finance doesn't, and so finance has gone, what happened? Your product tanked. Well, at least marketing knew and they understand it, so they're not freaking out, but finance is. Data augmentation for demos. Actually, I'm going to skip this one. I think in part 3, I'm going to walk through an end-to-end scenario where we'll go and we'll pull in some data that would provide some lift and show some real-life use cases. I'm anticipating 2 end-to-end scenarios, and we'll work on that at that time. Data cleansing. So again, what do we do if you have nulls, NAs, gaps? The big deal again is to understand what you're doing, quantify the impact, and know that you have not made a change that is detrimental to your output. You're really looking to minimally impact it, if at all, in a negative way, if at all, preferably improve it. So again, this is the big, the big data side, where this is when we get to pay for that pleasure of not having to provide a schema when we actually write it into our storage. Obviously, if you're pulling it out of your relational model, it's probably already pretty clean, but nonetheless, a lot of them aren't all that clean. So, and they may not be, because you might be looking at data that's different. You might be exploring things that are nobody's looked at before. That's really part of what all this is about, is to understand things or know things that you didn't know yesterday. So you be careful that you don't change the nature of the data, and you definitely need to document the modifications, and that should be discussed with the end users, the consumer, as well, so they understand that okay, here's what I did, and here's why I did this, and certainly get their feedback from any experts you might have in your business. And I'm going to save that for next week as well, so we don't run out of time today. So model selection needs to be consistent with the problem that you're trying to solve. There are numerous models within the Excel interface. There's 8 or 9 there that cover most things. It's very, very likely that kind of an A/B test, that the model you initially choose, or the model that you believe is the one you really want, may or may not be right. And to prove that, you should probably run several models, any that will either support your hypothesis that your regression model is what you're looking for, or that will actually give you better results. So one of the beauties, and I'll refer to Excel again, and one of the beauties of being data people is that you don't have to wait for some other team to do a lot of preparation for you. You shouldn't have to, I hope. If you have access to the data, and you have access to, in this case with Excel, an instance of analysis services, then you can fire up an Excel workbook and you can start running these algorithms and just check it out, and you can do it very fast. And that's what it's all about. You know, the faster you fail, the less investment you had, and the less it costs everybody. Then once you've got your model selected, then you need to test and train your model. So you run your models, you understand your inputs, you look to see, you know, these inputs drive these outputs. Again, run multiple scenarios and run, you know, it's not limited to just the inputs you use, but the values of the inputs. You may choose on a clustering model to require what they call more support, you know, more instances where this particular event occurred or this value occurs within your input data. And then you absolutely need to quantify the error. So this is where the big problem comes in, is not understanding what your error is. You may get results that look great. You really need to understand, you know, what the probability is, or what the range of the margin of error is, and what the less than optimal output is, whether it's, you know, less revenue than your midline, or you know, more cost than your midline. It's very important to understand that piece, and that was emphasized by all of the data scientists and all of the solutions implementers I talked to you know, over the last year and a half. And then you need to deliver results. How do you do that? You know, you need to provide your data, you need to provide your visualizations, your documentation, and then you need to manage expectations. You know, you need to be sure you don't try to sell a magic wand if it's not, and you really need to be careful about claiming anything is really a magic wand or silver bullet. It may look so good, but if you have a case where you propose a really significant change to an established process, you can expect to get a lot of pushback, you know, or if not just, you know, flat-out rejection, going, you know, there's no way we can do that. So part of the whole process would be to say, well, if I see a significant change, how can I actually implement this, and can it be implemented in a manner that would provide the means of proving that it's correct in a real-life scenario without causing harm to the business. So let's go back to Excel for a minute. So let's talk about some of the data mining over here. Probably one of the easiest to do is forecasting, and I've promoted for a long time that anytime you deliver a report to an executive, the first thing they're going to do with that report is they're going to look at, this is what I am today, and they're immediately in their brain going to be projecting it out into the future. And I've always promoted giving that to them, you know, without them having to ask. So give them exactly what they ask for, and give them this, you know, give them another option. So here I'm looking, this is a sample set of data that comes with the data mining add-in and example workbook. So we're going to go to forecast, and you'll see that it pops up this wizard, and we blow that up for you. And this is what it does. So it helps you build a forecast model based on existing, detects pattern series, usually blah, blah, blah. So what does it do? Let's get out of here. Let's go to next. So I'm going to let it choose the entire table, which it has done already. And I'm just going to accept defaults all the way through. I don't have to do anything. And it's coming back and has now provided this for me. So here, based on, you know, these sales history, we're looking for these three regions. It has now come back here, and it's actually given us this prediction. So here it's saying, well, how many steps are we predicting in the future? We can extend that out further. So you can see, if I were to see next month or next year, whatever, we can do that. What you really need to be careful with here, and this is back to that error, is that you understand what that is. So if you click on Show Deviations, it will show you your standard deviation. It'll show you what your margin of error is. And as you would expect, the further out you get, as you should expect, the further out you get, the greater your margin of error. If you're predicting very close to your last period, you should be in pretty good shape. But as a general rule, the further out you get, the more error you you can introduce. So in here also, you can click on this at a point, and you see the values that it's predicting for everything. I don't know that there's much else to show there. Okay. So let's go to this one's one of them that I really like, and it's not the wine itself, but the model I'm going to use. So what if you don't know what you're looking for? What if you're a case where I just want to see what's in my data and see what exists, and I will learn something about my data that I probably may not know. And if you don't have any idea, then you should look at clustering algorithms. So we're going to run a clustering algorithm on this. Back to this guy. So again, a cluster, what it detects groups of rows that share similar characteristics. So we'll go next. We'll select all of that data, the whole table. I'm going to look for, so the segments are groups. So we're going to look for, I'm going to tell it 10. I'm just going to leave it there. I happen to know that it comes up looking pretty interesting. So here it can automatically detect. It will look to see, well, what's a logical division of grouping. If I'm going to specify, if I were getting too fine-grained in here can be an issue, but like any average, if it came back and gave me two clusters, then there's a high probability that I have lumped a lot of inputs that are very dissimilar into those clusters, and like an average, that can be a very bad thing. So in any running any algorithm, or most of the algorithms, some set of data or percentage of data is set aside for testing. What that means is we're going to run, in this case, we're going to run this model against 70%, and we are training the model on that 70% of data. We're going to put 30% in reserve, and that gives us the ability to come back, and when we're done with our model and we think all's good, this is amazing, blah, 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 I can run the model against this other 30% and see if it actually gives us the results we're looking for. See if I get the same lift as I got from the data set I was using for training. So we'll go to next, and I think we'll just finish this up. This comes back with something that's really pretty kind of interesting. So it's built in clusters for us. It said, okay, I found these two clusters that have these, these ties, links between them, these similarities between them. What this does here is it gives you, it has grouped these inputs and created what you can see it says population, and there's actually a count of 4 rows that contributed to this cluster. We'll look at the properties of this cluster profile here in a minute. It has come back and has given us the 10 I asked for, and it has now said, okay, here's what they look like, and here's how they are related to each other. So the strongest links here, the thickness of the line represents the strength of the link between the clusters. So we'll look at this in a few minutes, but if I look at cluster 9 and cluster 4, I should see that they are similar in a lot of ways. So understanding here, going, well, okay, what is it that influences the behavior of cluster 4? Well, both of these seem to influence that pretty strongly. This has, well behind that, less of a relationship, less of an influence. I have these other clusters that start to build some relationship. So this may be where, okay, this, if you were looking at this graphically, you would probably go, I already knew that. That may be something I've seen before, but I might not know that this one sat over here, and I might not know that some of these relationships down here existed. So as we change our the strength of our relationship, it fills in the rest of the lines until eventually it relates everything to everything. So here's what our clusters actually look like. This is going to get a little geeky. Can everybody see this? All right. This gets to be a little geeky. So what this is saying is that for each of these clusters, these are the groups that have broke, like the alcohol variable, broke it into. So this column, it broke it down and said, okay, I'm going, this is my mean, 12.94, min and max, and it grouped everything, relative to those. So in this population, this is the entire population. So we have 125 rows, and in that 125 rows, this says that our this diamond, its placement here is on the mean, and the height of this is the standard deviation. So it tells me that, if I look across the entire population, I may not have a really good prediction, predictability. If I go look at one of these that's pretty skinny, our standard deviation is 0.56. Considerably smaller, you can see that by subtracting over here, considerably smaller, so our error is lower and our predictability or probability that this would exist is much higher. So it's kind of, again, take a little background to understand a lot of this, but I think that's why we're here. So is to get our feet wet and start figuring this stuff out. I will, like I said, in part 3, I will work through probably 2 end-to-end scenarios. I'll do one with Excel, and I'll probably do one with the new machine learning module for Azure. So here we can see our cluster characteristics. This is our entire population. If you want to see a particular cluster, you can see now that highest probability. So if we look back at our data, there are 3 types here, A, B, and C. So that's what this the probability that this particular cluster is type A. That's obviously, well, let's go back here. Actually, let's go here. This says A, B, and C, or B, A, C, I guess. So these clusters, this is all B, B, B. We have a mix of a little B with some A in this one. Okay, so any cluster that is, cluster 1 is going to be all A, cluster 2 is going to be all B. So if we come over here and look at it, we should see this. If we look at 2, we should see they're all Bs, etc. So you can see, how all these things line up. Back here, if you want to understand, let's go back to where we have something. Let's look at cluster 8 and cluster 3. So they have cluster discrimination. So we have let's go for cluster 8 and cluster 3, and they'll show the 2 of them together. So not all that strong here. You should have, offsetting. For phenols, we have, this segment that's that value 48 something, and this is very much the same. Here we have wherever we're duplicated. So ash, these two are relatively similar values, etc. So this shows you where the how the relationship was built. Have we been bored to death? It's kind of important stuff to understand if you're going to do anything with the with the analytics is how everything, why and how everything relates. Let's go for what's a decent one here too. Where are we running this? So let's do an association. Nope. Let's see what a classification does against this. Blah blah blah. Okay, that looks pretty. I want to predict over here, predict bike buyer. So based on everything else here, who is likely to be a bike buyer? And classification is usually a binary, looking for a binary output. So percentage maximum, we'll leave that alone. Okay, it's running our model. And now it's going to come back and say, tell us people with, here's our links. The strongest link is based on age. So it is saying that greater than 67, 281, under 67, 4,900. So between 35 and 40, I'm sorry, less than 35 or greater than 40, and here we have our 35 to 45 range, which is come up with saying is good but not great. So here we have number of cars are influencing our decision on whether this 35 to 40-year-old. I'm surprised I don't see children in here somewhere. 35 to 40-year-old is likely to buy a bike. So age comes in first. Where a person lives comes in next. And number of children is the third, and number of cars is our fourth and the weakest predictor. Where are we at? Okay, I'm going to stop here because I want to show you something else. So another way to do this, and it's kind of ugly. This is what it looks like if you're trying to do this stuff in R, and I'll show you why I'm bringing this up. So this really kind of emphasizes how the simplicity of and the beauty of Excel. It is doing all of this. Actually, what it's really doing is this piece, which is actually a linear regression, is calling a linear regression model and passing these inputs. In this case, it's that empty cars data set. It's a collection of cars. They're looking at predicting mileage based on transmission type, horsepower, weight, cylinders, number of cylinders, and displacement. So R is really nice for doing this sort of thing. It's really quite simple once your data is in in decent shape. And it's also fairly simple. This is more complicated than it needs to be. Shows you what this is actually plotting it. And it puts out something like this. This is a project I just turned in a couple days ago. So just to give you some idea of what it amounts to. This is an exercise against a really simple data set. And this is very much what you would need to deliver to execs or whomever to explain what you did, probably in simpler terms than this. So we explain our problem, we explain our data, we develop a hypothesis. Here's the empty cars, the raw data itself plotted out. Here's the miles per gallon figures for this list of cars, ordered it by increase, and then here's all of the input, the parameters, transmission type, horsepower, number of cylinders, that's our quarter mile speed, the D, car weight. So we're looking for patterns in here to say, okay, this is where you might choose what model you would use, or to make a wild guess to say, gee, none of these by themselves look like they really would drive this. Is anything here the transmission type? If they were all up top on this end and all on the bottom on this end, this is 0 is automatic and 1 is manual. If they were all grouped and there was no overlap or very small overlap, you could say, well, the transmission type is an absolute. It looks like it's a very strong predictor. It is at the extremes, in fact, but it is not, certainly when you get into, these mid-quartiles or second and third quartiles. So that's really kind of true in a lot of places. We have our cylinders, it looks like our 8 cylinders get worse gas mileage than our 6 cylinders, get worse gas mileage than our 4s as a rule. But again, there's, that's reasonably clear, more so than some. Weight can be all over the place. Anyway, so it's all about looking at your data, understanding your data, and then working through it to do your training and such, and eventually coming down to your variances and looking at, these are the numbers that I don't see in Excel and I have to find because they're really very important, because these estimates here, like in this case, if I use just automatic transmissions, it says I would expect a 7 more miles per gallon out of a car that had a manual transmission over an automatic, which, doesn't smell right, doesn't smell good. What it really comes down to is that our automatic, as we're looking at about a I think the number is 1.3 by the time it all got was said and done. So by itself, automatic was not good, but when you lump all of these together, you actually get a fairly good predictor, and the more of the parameters you add in, some more strong than others. Cylinder displacement first, cylinder, which is very closely related to displacement. Obviously, weight was next, horsepower, and behind that came the transmission type. So understanding your data and looking at it to see if it actually makes sense, forming a hypothesis, going, well, this, looking at this, I can make probably understand what's going to seem reasonable. Are there any giant surprises, and can I prove, here that, my margin of error is small enough against my prediction that it would likely hold true. So, done with that. I'd like to jump over to Azure. Get this out of the way. So I've got a cluster up and running, and I've logged into their new data mining console. So what it gives you is, I came over here and I chose to start a new experiment. Here it's built a machine learning environment for me, and I'm going to go sign into that environment. And here is where all the fun starts, and this is really the beauty, and I promise I will have a model built out in this because it really takes a lot of brain damage out of this. So I want to build a new experiment. So here we go. Let's open. Okay. So let's just start over. So Azure, they always have the new buttons down at the bottom. We're going to create a new experiment. So this, gee, does this look like anything we've seen? I want to take a piece of data, blood donation data, drag and drop, and I want to profile it. I want to understand what it looks like. So let's go statistical functions, I think is where I want to go. Descriptive statistics, drag it over, connect the two, and quite literally run it. And we're here, we can watch and see that it's starting, finishing. It shouldn't take it very long. I'm only running on a single node cluster. And when it's done, you can come here and say, I can save the output, obviously, or we can visualize it. So this will tell me, you know, all of it really is just profiling your data for you, but it's telling you for each of your columns of data, count of rows, unique values, providing, you know, min, max, means, deviation from the mean in the quartiles, just like that without doing much of anything. You have you've done a pretty exhaustive analysis actually against your data to really understand what it looks like. You do of course have all sorts of stuff here. They've got quite a lot of data sets. You can, in your saved data sets, if you have loaded any into your Azure storage, those would show up there as well. So outside of statistical functions, basic stuff, linear correlations, etc. You have all of your machine learning. So here we can evaluate. So we have our clustering, all of our different models. Like I said, they're all drag and drop. They all get a little more complicated as you start looking at them. They've built out some. I'd hope to find one to show you in here that's really simple, but none of them really are. Let's just go for whatever. So this will pull up a model they've already built. Obviously, not for the faint of heart. One would have to really understand what they're doing here. Let me try to blow this up so you can see it. So they're, this includes all of their data manipulation, data cleansing. They're adding columns, removing duplicates, etc. Everything you can imagine you can do in this interface. And this, you can do this as opposed to writing, pig scripts to, to move the data around and clean it up, and it really takes all the programming out of it. You still have to understand what the inputs are. You still have to understand, when you drag these over, you get the same, you saw in that, here, what do we have to include, what do we have to plug into it. So definitely some learning here. I will try to bring you up to speed on that next week. On Tuesday, 11 o'clock. Like I said, I will put one example together using Excel end-to-end, and I'll put another example together using build my own model out here in the Azure Machine Learning. So I think that's, let's go back to my slide deck real quick.
Michael, it looks like your screen
Do you
is
have,
frozen.
oh, it is?
Mm-hmm.
Is it showing resources now?
Nope.
No. Oh. Okay. Well, let me go. What are we showing now?
It's still on the Azure.
Interesting. I did have a little bug with it this morning. It was, I'm actually using Firefox because it had a problem with, problem running in Internet Explorer.
Mm.
Yes. I'm going to close them all. Okay.
Okay.
Now do you see it?
Nope. Probably just a glitch. Sorry about that, everyone. But if you do have any questions, if you wouldn't mind, go ahead and typing those in the questions box, and we'll go ahead and get those answered. Yep. All right. I guess we don't have any questions. Michael, do you have anything else to add?
If you can't see my screen, if you do have questions, I will post this deck, and it will take me a few days to get videos put together on, certainly more complete videos than what I just did. But if you go to iHeart, H-E-A-R-T, bigdata.com, I have last week's deck out there, and I have all the PowerShell scripts out there. I'll be updating that on a pretty regular basis over, actually for all time, I think, until I die, of course. But anyway, go out and check out my site. Take a look at presentations and tutorials, and most of this material is out there or will be out there shortly.